what do I consider under the topic timber?
Yes.
That includes the standard products like CLT,
yes.
which is softwood.
Yeah.
Normally used in the Americas and I think partially also in Australia.
Oh, yeah.
In Europe, we have a tendency to translate CLT, which consumes a lot of timber.
You have a tendency to
translate the abbreviation CLT, which is for cross-laminated timber, which consumes a lot of timber. Yes,
oh my God!
It's an ineffective material. I had a discussion with colleagues doing a high-rise building, the Hout in Amsterdam.
Can you spell it for me?
Hout. H-A-U-T.
H-A-U-T means high?
Holz. Timber in
Hout means
Dutch.
timber in Dutch.
Timber in Dutch.
Oh, okay.
Wood. So, wood in Dutch.
Okay, thank you. So, so you've got a nickname for CLTs, consumes a lot of timber. Amazing. Tell me more.
Well, we come to details later. Then here in Germany, there's a lot of use of 1D elements, beams and columns that are made of glulam.
Oh yeah, glulam, yeah.
Which CLT has a standard strength of 24.
24 what? How do you describe that to someone who doesn't understand?
Newton per millimeter squared.
Newton?
Per millimeters, over millimeter squared.
So that's the measure of strength.
That's the measure of strength. Yeah. That's a standard product.
Yeah.
With glulam, it's, yes, you can use 24. There are grades going up to 30 or even 32. That allows a lot more flexibility. And there are different ways to compose the elements. There are like high quality selection of the elements or low quality selection that allows to play with the costs depending on what you need. That is a product. Then the next thing is using laminated veneer lumber. That is, or best known is the Finnish product Kerto from Metsä wood.
Can you spell that for me?
Kerto, K-E-R-T-O. And the company is Metsä wood.
Metsä wood, right?
And they're using 2D elements, but also cut the 2D elements back into beam or column elements. So they produce thin strips of that.
Do they pack it together or is it just a veneer?
Laminated veneer lumber is the same build-up as CLT.
It's cross-laminated, yeah, but cross-laminated instead of it's not.
With a veneer strength of 1 to 1.5 millimeter. So the products go up to 30 centimeter. That has a lot of layers. And with the huge number of layers, it is really capable of carrying loads in two directions. While a typical CLT board spends 90% one direction and only 10% the other.
I never heard that before. That's interesting.
Depends on the layers. So timber only works structurally along the direction of its grain. And if you have a 3-layer build-up, then one direction, it's the 2 layers top and bottom that span one direction. And the other way, it's only 1 layer in the middle spanning the other way. So that comes up, well, it's more obvious with the 3-layer build-up than with the 5 or 7 or 9-layer build-up, but that is something to look after. In terms of geometry, it's even if you can do 2D elements, they are kind of limited in production. You can do huge lengths like 30 meter. You can do 50 meter, but it's tricky to get them on the street. Technically, length is no issue. The width is limited by the machines. So it's 3 meter for the normal products, or 2.5 meter. It's up to 4 meter with Cato. They have simply bigger machines. And the thickness is a third dimension that normally is something like this, 30 to 40 centimeters.
Wow.
So in a nutshell, the proportions are 1 to 10 to 100. Thickness to width to length.
Oh, gee. So that's why you say it uses a lot of timber.
Yeah.
Okay. So what's the, what do you like to use timber for? What's the most application that you use it for in Germany and Europe?
Everything. Still everything. We looking into applying additional materials. Like we are in contact with some companies using bamboo, which is a kind of timber, but officially it's a grass.
What do you think of bamboo?
Very interesting stuff. It has a strength, looking at the numbers of Newton per millimeter squared, up to 40 or 50.
Oh, really?
Twice as a normal softwood.
Wow.
We look into hardwood. Beech and oak are currently developed to provide us with materials up to 75 Newton per millimeter squared. So it's more expensive, but if it's 3 times as strong, it doesn't matter if it's twice as expensive.
Because you use less of it. You can go to a thinner version.
Yeah.
Fantastic.
Then we don't use or gave up on using single elements like a column or a beam. We're looking at the whole building and consider how to build that. That can be 2D elements like facades or slabs, where we then install everything on the facade, including the windows, the insulation, the weather protection on the outside, plasterboard on the inside if required, fully compose these elements and bring that to site. It's just installed. The next element is fixed to it, and that's it. With slabs, it's the same. They are produced with whatever is required in screed. If you want to span longer distances, we start using timber concrete composite, adding a concrete...
Timber and concrete, yes, together like...
a concrete slab with timber beams below, connected for shear forces. We are currently kind of varying options. Like at the moment, we have a project in Portugal.
In where?
Portugal, near Porto. And the client...
Is that in Germany? P-O-R-T... Well, how do you spell it?
Porto?
P-O-R-T...
P-O-R-T-A. Yeah.
Porto, okay. Oh, thank you. Yeah.
And they are... the client is a company having... kind of building their production facilities to include also timber production. And we are looking at a small tower, small means 7 stories, and consider how to build it. Currently, we are discussing the slab structure and said, okay, solid timber, like a CLT slab, is structurally okay, but you have an issue with fire, acoustic, and dynamics. It's
acoustics.
Timber has no weight; it has no acoustical insulation.
Oh.
Using that in no matter offices or residences, you have to look at heel drop or people-induced or impact sound transmission from floor to floor. And timber with no own weight or hardly no weight doesn't provide any insulation. So you would have to do...
I haven't heard that before. That's interesting. Yeah.
You would have to do a screed.
A screed.
Screed.
What's that?
Finishing. Like,
right. A screed.
Yeah, screed.
Yeah.
Cement-based topping.
On top of the timber.
On top of the timber.
So you're spoiling the look of it.
Yeah. To to make that effective, you put below a sound insulation layer to make the extra concrete or extra screed layer more effective. So you have two different independent systems with a spring in between, so you can tune it to act to different frequencies.
My goodness.
When having built that up, somebody said, well, why not get rid of the insulation layer and connect the concrete to the CLT board, make it a sandwich, a structural sandwich that reduces the amount of timber, reduces the amount of concrete, because we have the whole depth acting structurally. That is how companies like KLH started the building. KLH is German or Austrian for CLT.
Yeah, I've heard of them, yeah.
So they are producing timber concrete composite elements based on a CLT board with a concrete topping. For the project in Portugal, the client said, well, longer span, okay, then it's beams with concrete. We have a weight limitation, it's okay. Then we start replacing concrete with timber. So we are currently discussing a system where we have a thin timber layer, that might be LVL or CLT, with timber beams, and a composite concrete on top. So a three-system element that has still the structural depths we would like to see, using the timber interlayer as spacer between beam and concrete topping, but having the composite action between concrete, timber and timber, we still have the full height.
So you're still experimenting, really, with ways to use timber and, so what's your motivation for using timber, or your client's motivation? Is it carbon? Is it, is it cost? Why are people using timber?
Oh, it's for everything. Well, it's just a cool product.
It's a good product. Why do you say it's good?
Well, it looks not.
It looks good.
It has rooms with exposed timber surfaces have a completely different atmosphere.
They do, yeah.
It's also kind of measurable because it deals with the humidity in the room, kind of leveling the day-by-day variation of humidity by absorbing too much and releasing when it's below.
That's interesting.
So it's leveling that kind of bit. So that's one behavior effect. Then it's, if used correctly or wisely, not doing everything in CLT, for example, then it's a interesting product cost-wise. It's still challenging, so there's a tendency, especially if the market is low. That was shortly after Corona the case. Then the Americas, especially Canada, bought all their bought all the CLT that was produced in Europe. So the prices here
went
up by factor 3 or so.
Really?
Yeah.
Wow. So, have they stabilized now or come down?
Yeah.
Have they come right down to where they were before? Never.
No, nothing came down to where it was before. But it's reasonable in comparison with concrete or steel costs.
So Germany also produces timber. I know Austria does. Yeah.
We have the biggest production of the earlier mentioned hardwood materials is in Germany. That's Pollmeyer doing these beech LVL. That's a very interesting product. But yes, indeed, we are testing. So the client says, I want something that is unique. Interesting phrasing was, but overdo it. So a little bit innovative, but
don't overdo it.
Yeah.
Okay.
So okay, we can do. I found a system we will be looking into. I'll liaise with connector suppliers to make sure that it's doable using a different type of connection we haven't discussed for the last months. So that's one. Currently, we are doing a research project with the University of Berlin, looking into system variation or system optimization. As I said, acoustic and dynamics are governing the utilization of the timber elements. The structural utilization is negligible, like 50 or 60%. The important thing is, do people like it when the floor bounces back? This is so we are looking into optimizing the dynamic and at the same time acoustic behavior to figure out if we can kind of raise the utilization of timber, make it more effective in use. So if everything, acoustic and dynamics and structure, are utilized to, let's say, 80%, the overall material consumption goes down. And
right, so timber can actually save your overall consumption of material.
Yeah.
So less concrete, less steel, but you still have to use steel, do you? And you've already mentioned concrete. Do you need steel? Because I mean, I always understood that if you have something in timber, very tall buildings, they need to be so thick at the bottom, you're losing a lot of floor space.
Okay, that's a point. There's the idea in Japan with Fujimoto, Takamoto, the forestry industry decided to build a timber high-rise for 2035 that shall reach 350-meter height to celebrate 350 years of being in the market. Structurally, it's doable. For the use of timber, it's
extravagant?
No, just nonsense.
Nonsense.
You get a lobby at ground floor where you have columns at, say, 6 meter spacing with a dimension of 2 by 2 meter, which is not extremely sexy.
No.
We are looking into optimizing the things, which is not including the ultra tall buildings. So
it's more for medium and low scale buildings, yeah. Interesting about the moisture. I haven't heard that before because a lot of people are very concerned in Australia. You know, Passive House, the German built, the German design system.
Yeah.
There's some architects that actively oppose it. You know, in Australia, we have a lot of leaky buildings. You know, we build houses very badly. A lot of holes and air comes through. So if they're in the, you know, sort of Queensland in the warmer areas, they say it's not appropriate. And a lot of Passive House, I think, uses timber. So, you know, is there a problem with mould in Germany?
No.
No.
Because we have the Musterholzbaurichtlinie. That's a very, very nice document.
What does it translate to, if possible?
It's standardized guideline to use of timber. That is kind of an extension of the Eurocode 5 that defines how to calculate. And the Musterholzbaurichtlinie is kind of how to apply the code to a production.
So it's a building code, yeah.
And it has a lot of details. For example, when prefabricating timber, you need to assemble it on site. And there's a very detailed description how to deal with joints between the elements. So it starts with 2 millimeter. That's a joint you don't have to worry about. If it's more than 2 millimeter and below 5 millimeter, you start dealing with it to make sure it's not an issue for fire. At the same time, whatever sealing you apply also deals with humidity. That's a side effect. Humidity during construction is an issue. So we currently have a project on site, kind of half on site. They have
gets wet, etc.
A little facility there where they store the building modules, and now they wait for a dry period of 2 days to install it rapidly and then close the roof.
Yeah.
Once the roof is closed, the measures against moisture on site or during construction are still in place. So they are preventing issues like mold. We have to run detailed calculation in terms of building physics. So the build-up of the facades is using timber, no matter CLT, glulam, as a structural element. Then we have insulation on the outside. Insulation at the same time prevents fire from the outside using rock wool.
Rock wool, yeah.
Only then we have a waterproofing barrier. What's that? Luftspalt. A thin gap and an outer cladding.
A thin gap for the air insulation, which is very powerful, isn't it?
Yeah. To allow ventilation.
Yeah.
So real moisture like rain will stop at this barrier, the membrane, and will be ventilated away, so it won't stay in that gap and cause any moisture issues.
And do you need mechanical ventilation inside to move the air around to stop mould?
No.
You don't, but in passive house you do, don't you? Isn't there that system, whatever it's called?
It's not about mold. It's
not about what? Sorry, mold. It's about something else.
It's about
ventilating the air and cleaning it. Yeah.
It's I'm not quite sure if it's still valid. We have these energy reduction regulation. And I recently looked at documents of a project we did a few years ago. And we had mechanical ventilation for residential building for every room, simply because the rules said so. Nowadays, we are allowed to simply open the window. Like in office buildings, you don't have to use mechanical ventilation if opening the window is sufficient. There are buildings built on an older regulation that still has no requirement for mechanical ventilation. There are measures of dealing with ventilation, kind of forcing natural ventilation. So there's an electric system that automatically opens the windows for 5 minutes and close them afterwards. That does the trick for ventilation.
Yeah.
In terms of mold, it's quite advantageous. The timber is not completely watertight. It has just the amount of
breathability, like it breathes.
Permeability. Yeah. You can use that to deal with water transport from inside out.
Yeah.
So during construction, there's a certain tendency, if the concrete is done on site, doesn't have to, but if it's done on site, it takes a year or so until the rest of the humidity has evaporated, and then it simply goes through the permeability of the facade. If it's in winter, if it's very wet outside, it's raining, or not winter, it's cold outside, it's raining, and it's dry inside because you're heating too much, the water goes the other way around and helps increase the humidity in the rooms.
Yeah.
Not perfectly, but a little bit. So there's no need to prevent this permeability.
You actually allow it to happen because it's actually healthy. Yeah. It's interesting. There's a lot of misconceptions in Australia, with passive house.
Without the in Australia.
Yeah. Yes. There's a lot of people are very. It's another controversial issue.
Yeah, we had the discussion like 15 years ago. Yeah, we had a research project in Austria, funded by the government, with a Austrian developer, and out of it was a system developed called CRE. CREE.
Oh, yeah.
Incidentally, it's quoting some of the Native Americans, That's one tribe called Cree.
Yes, I've heard of that.
And they are just using the same abbreviation. That's something with energy efficiency.
Yeah.
Forget what the rest is about. And we did that project and had a big press conference where the owner of the developer was around and some other people. And there was a question, the usual one, timber does burn in fire. Are you not scared to? And the owner said, we are going to move into that building once it's finished. So no, we are not.
Because it chars, it doesn't burn, doesn't it? Isn't it? Isn't it worse to have
it burns?
It burns,
but it behaves much.
You can get out of the building much quicker. It takes. Isn't that the thing that it chars? It doesn't quickly. If you've got a whole lot of artificial materials, they'll just go up, and you'll get toxic.
It chars.
Yeah.
It burns a little bit slower.
Yeah.
But it still burns.
It still burns.
But it burns predictably. So if there's a fire in the room and the wall is out of timber, it starts charring with 0.7 millimeter per minute. That has been confirmed by many tests. So it takes 90 minutes to get 7 centimeter of the wall into black charcoal.
Wow. And how does that compare with other materials, like conventional non-timber material? I suppose if it's solid concrete, you're fine, but...
No, it's not. Solid concrete has a problem that at a certain temperature, the water in the molecular water starts evaporating and kind of blows away the concrete cover, which is normally only 3 to 4 centimeter. If that's gone, there's steel and fire is not a good combination. So there are calculations, there are measures to make sure it withstands that. But damages can still cause issues. Steel is quite tricky because its behavior is non-predictable. So exposed in the fire, there's nothing happening for the first, say, 30 minutes. And at a certain point, it reaches 600 degrees. And then the steel says, I'm off. It collapses without pre-warning. So there might be...
The World Trade Center, for instance, in the US, the September 11.
Yeah.
That all collapsed on top of each other.
That was the kind of second stage collapse.
Yeah.
The airplane impact kicked out 2 columns, and that was the downside. They had a steel staircase. It destroyed the staircase, so there was no escape anymore from above. And then the fire led to the columns collapsing after, I don't know, 30 or 40 minutes it was. And then the impact of the whole building going down broke down the whole building.
So when you're talking about different materials, how do they compare, the method of building a building? What is considered most fire safe?
No, not in general. So it's the other way around. We discussed with our fire engineers that we do buildings up to, let's say, 60 meter, not arguing about plus minus 10. That's a reasonable height. And we do the first escape route with a concrete staircase. Back to 9/11, a concrete staircase would have survived the impact of the airplane.
Yeah, I think they're saying the way Australian buildings are built, that can't happen.
At least one of the staircases would have survived.
Yeah.
Not the one with the direct impact, but the one next to it would have survived. Concrete does not burn. It has no fire fuel load in it. So then next to it, we have the rest of the buildings, columns, walls, and slabs. And that can be done in concrete, in steel, or in timber, or in combinations of them. Concrete has a lot of carbon footprint, is heavy, but behaves relatively moderate in fire. Steel is light, is expensive, normally comes with a proper carbon footprint. Normally it says, well, there are green steel products nowadays where they use
are they
reuse
properly green? Do you think that are you happy with their greenness? Do you accept it?
To a certain degree.
Yeah.
Because
you can recycle them, I suppose.
Yeah.
Theoretically, yeah.
One of our suppliers, not telling you his name, they have brochure saying, well, we do the most green steel you can imagine, and on the brochure all steel beams and steel columns are painted in green to make it obvious even for the amateur. Okay. So that's overdoing it a bit. But in principle, yes, reusing steel is a good idea. To timber, it's funny because we're discussing that on kind of every meeting, no matter a researcher. Currently, the code says timber lasts 50 years, or every building lasts 50 years, and timber is burnt afterwards.
It's burnt what, sorry?
Burnt. After use, after 50 years, it's burnt. So, first question, why don't we use it for 100 years? Why don't we use it for 200 years? Look at the pyramids, look at the, that lasted about 2,000 years. The pagoda in Asia, churches in Scandinavia, or buildings in the Alps, 300, 400, 600 years, no problem. Timber can do that. Other materials can do that too. And the most stupid way of dealing with timber after a relatively short lifespan of 50 years, to burn it.
Is that what people do?
That's what the code says we do.
Yeah. The code says that, okay.
Yeah, the code defines that there's only way of doing that. So, okay, what happens, we're discussing that in our research project, we have, a circular company, La Concula, on board with the research team. And we said, look, there's a standard way of calculating lifespan 50 years, burning the timber for energy production, releasing carbon at the same time. So that's the way the code defines that. So what if we go to the end of life, 50 years? Okay, move the people out, repaint the whole building, give it a new color, clean the floors, and use it another 50 years. We can calculate that. That's not code conform, but we can calculate that, and big surprise, it works even better. There are many ways of dealing with a circular approach to timber. You can use connections. The old way of building block houses, that's timber connection without metal. That's or the Asian Japanese carpenter. That's artwork. What they partially do with connections. You can do the same nowadays. Having maybe a screw here and there to kind of fix the positioning of the elements, but for the load transfer, use timber to timber connection. That's doable nowadays. And obviously, a simple connection where you have a beam and put another beam across can be.
So they can last longer. Yeah. And does the code? Do you think you're trying to do this research so you can encourage the code to change and accept?
Yeah.
A new method. Yeah. Yeah.
We means there are many people, many researchers doing that, and. For example, in Arup, we have also some people sitting on the Eurocode committee. So that's two colleagues from the UK office sitting on the Eurocode committee, looking into what is allowed, what is not allowed.
So that's got to change. It's got to be an evolving thing, doesn't it? Yeah.
It is still evolving. Currently, we expect a new code, a code update or something else every year. So on a regular basis there are updates. The research goes back into the code.
Tell me, do you have opposition to the code being improved in terms of energy efficiency and safety like we do in Australia? In Australia, we have big opposition to, the code tries to increase energy efficiency and make houses more comfortable and buildings, but there's a lot of people in the industry who fight that.
Okay, in our case, it's not the code because the codes I mentioned is the structural codes, Euro Code 5 and timber guidance. There are codes regarding energy efficiency, and recently, means last year, there was an initiative in Germany. We have, for many purposes, buildings are classified in terms of fire, in terms of building permission application. So there are different classes.
Oh, yeah.
And they are normally just numbered. And somebody said, well, let's consider a building class E, where E is for einfach, which is in English simple.
Is what does that mean?
Simple. Simple.
Simple, yeah. Okay. Easy, the number one, yeah.
Some codes define the energy efficiency codes that if you want BREEAM, LEED, or some of these certifications, it said 2 years ago, to achieve the maximum points, you need a increased sound insulation, increased above the higher version of what the code already said.
Yeah.
Said, well, hang on a second. We quite often live in houses that have been built 100 years ago.
Yeah.
Timber floors. We are lucky that we can't see our neighbors. We are used to hearing them.
Okay.
And the standard acoustic requirement is already 4 times as good as the standard floor provides. So in the normal acoustic code, there's a definition. You can ask, the client can ask for an increased, that's another doubling the performance. And the certification, sustainability certification, used to ask for another doubling the performance. Then we are up to 16 times better than a normal residential building.
So that's in terms of sustainability certification. So
yeah.
There's, I suppose, some kind of, some equivalent of a Green Building Council.
Yeah. That's LEED, BREEAM. The German one is
BREEAM.
BREEAM, yeah.
Yeah. So how pervasive is that? Do a lot of clients want it? What's the percentage of clients that are looking for a BREEAM?
They started looking at it like 15 or 20 years ago. That was LEED, the American standard. And that was just to go on the brochure for the building. So we have the platin label on it, so we can ask for €2 more per square meter.
Yes, that's that was it, yeah.
Now people start looking into sustainability of buildings and figured that the certification not automatically means better buildings. Like this building class E looks into comfort criteria, acoustical performance. Isn't it sufficient to go for 4 times better than we used to build? Thermal insulation. We could go for the maximum as the code requires, or we could calculate how much more heating energy we use when we reduce the insulation, saving costs on insulation.
But increasing the energy that you need, yeah.
Yeah, but going for renewable energy with heat pumps or solar systems. Then
what do you think is better? Because that's a big question. Do we? You can make something thermally brilliant, and not use any energy, but you're using a lot of embodied carbon in the material. So where do you think where does it lie? Where's the benefit? Where's the overall best solution?
Somewhere in between.
Somewhere in between.
Having a smart approach, you'll measure the grey energy for your heating system, for your cooling system, for your insulation, and for structural performance.
Yeah.
And find the best performance, or the end. You have a third parameter with the building class E. You might adjust the target as well, so you are approaching from
But what's the
seaside.
demand? What are clients asking for? Like if you've got a corporate client, what are they wanting? Is it 5% want a highly efficient building, 10%? How many?
The other way around. All clients ask for cheaper buildings. Big surprise.
Big surprise.
And if you go for a smart building concept, optimizing grey energy consumption, and the cost of construction, then you can in the middle find.
Do they care about the operational energy though? When you say grey energy, do you mean embodied carbon? Yeah. So do they? I think if you've got a corporate client that's going to lease it out to another corporate tenant, for 5 + 5 years, they care about the operational energy, don't they? Do they?
They don't have to if they are going to kind of only develop the property
and then sell it. They don't care, of course. Like in houses in Australia, like build and flick.
Yeah. And here it's quite seldom that they are selling the property after it has been built. So we have had a new development here where the client said, I'm going to build that, I'm going to run that, and to prove that it works effectively. And after 10 years, I'm interested in selling it. But until then...
That's rare, is it? Not
with the 10 years, but a lot of clients just run the building after having built it, not selling it directly afterwards.
A lot of them do.
Yeah.
Right, so they do care about the operational side of it. Yeah.
And subsequently,
because energy is very expensive in Europe, isn't it?
Yeah.
Especially after Ukraine. Yeah, with gas.
Yeah, and then that changes on a weekly basis. So
I know. And especially in Germany, it's a big deal.
Yeah. We have a lot of regulations allowing the use of renewable energies. General wind energy is on the rise.
Yeah.
And locally on houses, nearly everybody now has a photovoltaic or solar energy system on the roof. Currently, there's a hype for what that called balcony energy plants. So you get a PV panel, square meter sized, hang it from your balcony.
Oh, I've heard this.
Get a smartphone sized adapter and just plug it into the into your socket. And
brilliant.
New buildings have to use the heat pump, I think they are discussing that, going back and forth, but I assume all new residential buildings have to use heat pump. And as it is obviously a good system, a lot of office buildings also consider heat pumps, at least for covering part of it.
Okay. What do you mostly work on yourself? What is? I didn't ask you what your role was at the beginning, so maybe tell me that now. And what kind of buildings you do? What's your role here?
Well, obviously, you might have heard of structural engineering. And I was recently trying to update my CV, looking into all the projects I did over the last 30 years. And figured there's nothing excluded.
You do everything, the whole lot, yeah. So, and the company itself, does it do quite a bit of residential building, or is it mostly commercial?
It's a question of the size of the project. We are, as a relatively big company, we're having a certain overhead, and we can't do a small house. No. Recently, we bid for one that's a student housing with 16 rooms. That is relatively small.
That's very small.
But we are interested in doing that. We are looking only for the structures part of it, because we want that module to be used on a different project that has then 160 rooms.
Oh.
So we're getting kind of, let's say, paid research on the small one to develop a system that works for taller and longer buildings, and just reusing the structural concept for the next building.
Well, thanks, Carsten. So looking ahead, just to kind of wrap up, I mean, what do you want to, timber is the big thing. It's big for us at the moment too. What do you think the future of timber is? If you're looking at 5 to 10 years, Europe seems to have a lot of timber because I understand you had some laws many years ago requiring farmers to keep some of their land as timber. So that was, we don't have the same rules, I don't think. But, so do you think timber has got, do you think in terms of materials going into the future, 5 to 10 years away, are you looking at timber? Do you look at new bio-based materials, composites? Where do you think the future's going?
Definitely at composites, because simply there is no perfect construction material.
Right.
We said that in discussion, there's a nice paper, Designing in Timber, that was written by several colleagues and myself, kind of advertising the use of timber. And we do that in a lot of articles, that we say, well, composite material is very good because it combines individual strengths of various materials, and in the end, it's performing better than the sum of the individual performance.
Yeah.
So I think new materials, new products. For example, Cato just came up with a new system. They're providing a ribbed slab system, while CLT has a slab system.
Yeah.
It's just
ribbed.
Cato provides the same span with using a thin LVL board on top and LVL beams below. The beams are only 6 or 8 centimeter wide, but this whole system spans also the 8, 9 or even 10 meter.
In timber?
In timber. It's no problem because it has sufficient structural depth.
Yeah.
It has, again, downsides because it's
got doubters. Sorry?
Reducing the amount of timber in the construction. It also reduces the weight, which means it's performing even worse in acoustic.
Oh.
So we are looking in combining materials. Currently, we have a research with another university in Berlin looking into the use of rammed earth. There have been
interesting rammed earth, yeah.
There have been several projects. Herzog-Dämmermann had a very beautiful one built with rammed earth arcs between timber beams.
Oh.
That's the project Hortus. Worth looking up images. It just looks cool.
Hortus,
H-O-R-T-U-S.
Oh, okay. Rammed earth, yeah, we're interested in that one too.
And we are looking into using rammed earth as a compression element in composite systems. Rammed earth is short name for many different products because it depends what you find on site. You might just find sand, then ramming it doesn't help because it's just sand. You might find something that is mainly clay that might
That's good, is it?
that might even be too brittle. So the perfect mixture is somewhere in between.
Yeah.
And there are still some companies that add a spoonful of cement to make it a little bit stronger, which is not the most sustainable way. But currently there's a broad research on how to use these materials. As I said, we're looking into different timber materials, like let's call bamboo one of the timber elements because it behaves similar.
Yeah.
The hardwood materials come to market. So there are new systems. We are doing research on how to connect elements of timber to make it a more effective system dealing with acoustic and dynamics. So there's
What do you do with acoustics? How do you solve the acoustic problem? With a layer of cement or concrete, you said.
We might do that with screed using. There's also an approach for using ramped earth. If we only look at acoustics, not at structural performance, we could use. There are ramped earth boards, clay boards, like 3 centimeters or so, that can replace a dry screed out of gypsum board plates, being significantly more sustainable. And with all these elements in mind, we try to find something that has, no, not the best, would be tricky, too many components, but a good combination of materials to have a
That's very interesting. It's usually the answer, isn't it? Somewhere in the middle, or a composite of things. That's very good. Well, thank you, Carsten. That was really interesting. I've taken up nearly an hour of your time, so I'm very grateful. Thank you.
You might have heard timber is one of my hobbies. So I'm happy to discuss that. Interesting outlook is that I'm meant to retire next year.
Oh. You look far too young for that.
Danke. The interesting point is that I'm already talking to colleagues at universities, colleagues here in the firm, to keep working on that matter somehow, because freelancer is no clue.
Yeah.
Because I'm simply interested in. We are at the moment doing too much research, too much developing new things that I would like to just stop looking at it next year. So I'll kind of use my bit of my spare time to keep talking to colleagues and see where we can push the use of timber, at least as one of the components of future buildings. In a nutshell, we said we prefer to have 100 mid-sized buildings than one 350-meter tower. Normally not quoting that one, but don't overdo it. We don't need high-rise buildings. No. It depends on the location.
Sure.
In Tokyo,
you have no choice.
You might build a little bit higher, but look at Berlin. Most of the buildings are 25 meter, like this one. There are some high-rise in between the Kleihuis, that's the one with the Beckhoff label on it, and the Murphy-Jahn here next door. These are 60-ish, but there are only very few taller buildings here in Berlin, so no reason to compete with them.
That's nice to hear, yeah.
One big tendency goes into kind of extending existing buildings. We have a lot of buildings with a flat roof. Modular concrete construction built in the 60s, 70s, and it's easy to extend them using timber modules. You might even do that when the buildings are in operation. You don't have to get the tenants out before you do so.
Yeah, and that's pretty cost effective.
Yeah.
Well, you've already got the land. You don't have to buy the land.
Yeah.
And the construction's good. Well, thank you very much. That was fantastic. I appreciate it. That's very good.